Alright, we are in week 2, day 3 of the course. It's Tuesday, and this is Introduction to Programming Logic. Okay, I went through announcements, talked about Good Morning Nyack on Mondays. We enhanced learning where they see links. We talked about Linux access, being able to access, and today we did some work on creating a simple code. Flowchart symbols, we talked about peer review of flowchart symbols. There's some work to be done there. So they're experimenting with that. And then we got started on programming control structures. Thursday, we are meeting MH 159, I believe. New classroom. If you go the STEM building over here, we have the new STEM building, and then we have this hallway going down to it through the science area. The classroom is way over in this corner. So this will be coming in from the west. It's all the way in the end. It's on the east end of the building. Or if you come down the hallway, you'll find us. All the rest of the rooms around there are labs and so forth. Alright. So, we talked about design. When you have something that you might be able to solve using technology, some type of problem, you got to have some idea, some general inkling of the design. The first step is what are you going to actually use technology. You have to understand the problem. We're going to talk a little bit about that. Before we get into that, I mentioned this peer review. We talked about the importance of peer review. We're going to use peer review for our designs. We're going to use peer review for our codes and make sure things are working. Okay? Top-down design. Let's just mention that briefly here and I'll repeat it. We have some problem. We did an example today in class. You analyze the problem. You design a solution. Develop the solution. This is where usually we code. And then you can implement it. Put it into use. And then, when you implement it, when you run into some more issues, you understand the issue, you analyze the new issue, design a fix the code, and implement your update. Okay? Now there's a lot more things that go into this, but this whole process is known as top-down design. And we're going to look at top-down design, and later on we look at bottom-up design. It looks kind of like this, but you start coding sooner than later in the process. So the whole thing is called structure and design. This top-down process. You make sure you understand the problem. You create a solution. For example, we're going to use some concepts of control structures. We have 3 main ones. The first one is sequence, doing things in a straight line, one after another. We'll talk more about that. Once you have this part, or at least a good start on that, then you can start developing the code based on the pseudocode or the flowcharts. And then we'll talk more about testing, documenting, and so forth. And eventually you implement. In the modules, there's a nice, under the learning materials for this unit, this is laid out, and the process is laid out that we'll be doing in class. Alright, control structures. Our first one is sequence, where you process the items in sequence. So here I have start module, or start diagram, and then the stop flowchart symbol. You notice the start has only one arrow out, the stop has only one arrow in. This is initialization box. For example, we let pi equal 3.1416. And this is not complete, but here we would input our information, process it, and then output the information. And we'll get into the details in there as we move along. It's really not too hard. But you notice the arrows touch the boxes. We flow down. Okay. Input, output boxes, one arrow in, one out. Process boxes, one arrow in, one out. Process, one in, one out. Output, one in, one out. Terminal boxes either have one coming out or one going in. Those are some rules that follow along in here with the design. You have an assignment where you need to organize those rules. Okay, so then here we did an example. I call it the dowel rod example. It's one that's in the code. The final code is in with the documentation for this module. But we talked about covering the outside of a dowel rod. And what we're doing, we're talking about just covering this outside and not the ends. Whoops. I gave them some test data. The students asked a variety of questions, and then they came up with, right here, how many square centimeters it would be needed for that particular example. Okay? We didn't do these two. Key thing, you have to understand the process. You gotta be able to do it manually before you can ask the computer to do it. Then we started talking about IPO. We got into the basics, and we'll talk about it almost every day the rest of the term. Input, process, output. We talked about what we're going to put in, what we're going to process, how we're going to process it, and then what we get out. IPO. You need to be able to do this manually before you ask the computer to do it. Alright, so we talked about finding the width, taking the width times the length to get the area, and then we output that area, the length, the diameter, and the width. And knowing these two, you could cut a piece of fabric that should wrap around the dowel. This problem, the way it exists, would be a sequential problem. We only ask to go through the process once and get an answer. But it's very important. It should be set up so we can add different data every time to get it to calculate. So we can add different data in order to get it to calculate. One more. Conditional, selection, decision, okay. Typically we use an if, but these are the words we use with this. Okay, it varies a little bit. That's decision. So typically I call it a conditional. So we make this diamond, and based on the diamond it's either true or false. Some people put yes or no, some people write out the words. Okay? Based on that, it goes one way or the other. It doesn't go both ways. It always comes back together with a connector. This is known as a connector, and then that continue your processing. Here could be sequential, could be more conditionals, and it could be iteration, which we're going to look at here to finish up with. So we have sequential, conditional, and now our last one is iteration. Iteration, a lot of people call this creating a loop. So the first one we're going to do, we have a connector, and then we're going to decide. This is called a leading decision. It's called a leading decision. If the decision is true, we process this and come back up. If the decision is false, we continue on with our processing somewhere else. This is often referred to as a do-while. And this is often referred to as a if-then. But the names of it, this is an iteration, this is a leading decision. Obviously then we have a trailing decision, which we'll talk about later on. So, to summarize, I'll pull up and we have at this point 3 control structures. These control the flow of either your design, your code, or whatever. We have sequence, we have conditional, based on some condition, true, false, oops, let me see if I can do a little better. Alright, and then we have iteration. And the type I showed was a leading decision. When I draw those dotted lines, what I'm referring to is there's more code there. True, stay in the loop. False, get out of the loop. Here, we always have 1 in, 2 out, always comes back together. Here, we have 1 in, 2 out, and it always loops back to a connector. 3 control. Alright, so that's a great start on that. We're going to do some design on Thursday down in The new STEM area, we're on the east end in what they call the sandbox classroom. It's way on the east end, northeast end of the hallway. And that's it for today.